Welcome to AskPrep, your trusted companion for NEET and G preparation. Today we will study about a very important topic of physics, which is center of mass and rotational motion, moment of inertia. Imagine a gymnast spinning effortlessly on a high bar, a figure skater executing a perfect spin, or a planet revolving around its star. All these motions are governed by fundamental principles of physics, particularly the center of mass and rotational motion. These concepts are crucial in understanding how objects move, balance, and rotate in various situations. When we observe an object, we notice that every part of it has some mass, and this mass is distributed across its entire structure. However, there exists a specific point where the entire mass of the object can be assumed to be concentrated for the sake of analysis. This special point is called the center of mass. The center of mass behaves as if all the external forces acting on the object are applied at that single point. This property simplifies the study of motion significantly, making it easier to predict how an object will move when a force is applied. For simple symmetrical objects, like a uniform rod, a sphere, or a cube, the center of mass is at the geometric center. But for irregularly shaped objects, finding the center of mass can be more complex. The position of the center of mass depends on the mass distribution, and in some cases, it may even lie outside the physical body of the object, such as in the case of a ring or a boomerang. The concept of center of mass is essential in various real-world applications. Engineers consider it while designing vehicles to ensure stability. Athletes, especially gymnasts and divers, use their understanding of the center of mass to execute precise movements. Even in space exploration, scientists calculate the center of mass of spacecraft to determine how they will move in response to external forces. Now, let's delve into rotational motion. Unlike linear motion, where an object moves along a straight path, rotational motion involves objects spinning around an axis. The study of rotational motion allows us to understand how planets rotate, how a bicycle wheel spins, and how a fan operates. Just as force is responsible for linear acceleration, torque is responsible for rotational acceleration. Torque is the turning effect of a force applied at a certain distance from the axis of rotation. One of the key quantities in rotational motion is the moment of inertia. It is a measure of how much an object resists rotational motion. In simple terms, the moment of inertia is to rotational motion what mass is to linear motion. It depends on both the mass of the object and how that mass is distributed relative to the axis of rotation. Objects with mass concentrated far from the axis have a larger moment of inertia and thus require more effort to rotate. When we move from translational motion to rotational motion, another key concept comes into play, the moment of inertia. While mass determines how difficult it is to change the translational motion of an object, the moment of inertia determines how difficult it is to change an object's rotational motion. It depends on both the mass of the object and how that mass is distributed relative to the axis of rotation. The farther the mass is from the axis, the larger the moment of inertia, which means more effort is required to change its rotational motion. Every rotating body has a unique moment of inertia based on its shape and mass distribution. For example, a solid sphere, a hollow sphere, and a disk of the same mass and radius will have different moments of inertia. This property plays a significant role in various applications, from designing mechanical systems to understanding planetary motion. For example, a solid sphere and a hollow sphere of the same mass and radius will have different moments of inertia. The hollow sphere has more mass distributed farther from the axis, making it harder to rotate compared to the solid sphere. This is why different objects behave differently when rolling down an incline. The one with the lower moment of inertia will reach the bottom first. Understanding moment of inertia is crucial in various fields. In sports, figure skaters control their rotation speed by adjusting their moment of inertia. When they pull their arms close to their body, their moment of inertia decreases, and they spin faster. Similarly, in engineering, the design of flywheels and gears takes moment of inertia into account to ensure efficiency in machinery. To understand the significance of the center of mass, imagine a system of particles. Each particle has a mass and occupies a position in space. The combined effect of these particles determines the location of the center of mass. If a force is applied at this specific point, the object moves in a straight path without any rotation. On the other hand, if a force is applied away from the center of mass, it causes the object to rotate. This is why the concept of the center of mass is essential in understanding how forces influence objects. Another fascinating aspect of rotational motion is angular momentum. It is a property of rotating objects that remains conserved unless an external torque acts on them. This principle explains why a spinning top continues to rotate and why planets maintain their orbits around the Sun. The principles of center of mass and rotational motion are deeply interconnected. For instance, when an athlete performs a somersault, they adjust their body position to change their moment of inertia and control their rotation. In space, astronauts experience microgravity, making the understanding of center of mass essential for their movements inside the spacecraft. From understanding how celestial bodies move in space to designing high-performance vehicles, these principles have widespread applications in science and technology. The deeper we explore these concepts, the better we comprehend the mechanics that govern motion in our universe. By mastering the concepts of center of mass and rotational motion, students can not only excel in exams but also develop a profound appreciation for the physics that shapes the world around us. These principles form the foundation of various advanced topics in mechanics and engineering, making them essential for any aspiring scientist, engineer, or medical professional who seeks to understand the physics of movement. Thank you. This is AskPrep, your guide to mastering NEET preparation. Let's decode complex topics and simplify your journey to success.